Hello everyone, welcome back to my channel. I hope you all are doing well and continuing your practice. In today's video, we are going to continue our Unit 1 exercise session and solve the preceding questions starting from question 19. In the previous videos, we completed the first 18 questions. I hope you have practiced those problems and understood concepts, formulas, and approach required to solve them. So let's continue our practice and start today's session with question number 19. Question number 19. The drag force F acting on the sky driver is given by the equation F is equals to 1 by 2 C rho A into V square, where C is a constant, rho is a density of air, A is a cross-sectional area, okay, of the diver, and V is the speed of fall. Show that C has no base unit. In this question, we have to prove that C has no base units. For that, we have to write this equation here and make subject C, and we got 2F upon rho A V square. Now, we know force has a unit Newton and which is about kilogram meter per second square. Substitute here and rho means density means mass per volume. Put is here A. A means area means meter square. And last V means speed means meter per second. Here it has a square, so we have to do square as well and try to simplify it. And we got meter, meter cube, second square, and denominator we have a meter square, second square, and we got one. Means there is nothing to left. So C has no unit. Means one is a constant. So C is also a constant, as means no unit. And this is 19th question, and it is very simple problem. Now we go on next question number 20. In question number 20, use base units to check whether the following equations are balanced or not. Okay. In A, they give pressure is equals to depth into density into acceleration of free fall. Now solve A. In A, they give a formula like pressure is equals to depth, density, acceleration of free fall. Now we have to prove LHS is equals to RHS. So take first LHS. LHS has pressure. Pressure means force per unit area, means F upon A. As I mentioned earlier, force has a Newton, SI unit. Okay, so means kilogram meter per second square. And area has a meter square unit. Now by simplifying it, we got kilogram upon meter into second square. Now it is all about left hand side answer. Now the right hand side they give depth. Depth means it's kind of length related to length. Like it is a cylinder and it has some height, or you can say a depth, which is measured in meter or SI unit is meter. So we write here meter, density, kilogram per meter cube, and acceleration. Acceleration means A as a unit meter per second square, and velocity has a meter per second. So be careful when you deal with A and velocity. Okay. So here I put meter per second square, and we got the answer kilogram upon meter into second square, and which is same of left hand side. So we can say LHS is equal to RHS. So given equation is balanced. Okay, this is all about 20A question. Now, in B, they say energy is equals to mass into speed of light square. Now, for B, write this equation and take again a left side, which is energy. Energy means joule. Okay, here write a joule, and joule has base units conversion is like this. Okay, kilogram meter square per second square. In the case of Newton, which is a SI unit of force, is like kilogram meter per second square. If you multiply meter here, so you get joule. Okay, so again, joule can be written like this also, Newton into meter. So you have to remember Newton's formula, base formula, and Joule's base formula. Okay, try to remember it. Now, in Joule, we see kilogram meter square per second square. It is about LHS. Now, in the right hand side, we have a mass. Mass means kilogram. And the speed of light, weather speed. So we have to put meter per second square, second, whole square, because we have a square here. So anything related to speed or velocity, meter per second, its unit. Okay. Now simplify it, and we got the same answer. In we got the answer in LHS. So here also we can say equation is balanced. Now this is all about question number 20. Now we move forward in question number 21. Says the work done stretching a spring by a extension x is given by the equation. Okay, try to understand the question. If uh, there is so spring, okay, this is a spring, and take this is the mass, and you have to stretch. You have to do force here, pull the mass and block, and this is spring, okay, and it is extend by the x amount. Okay, let's see, this is a zero or this is a x. It is a stretch by the x meter or centimeter, you can say, and the equation is given by this. This is the work done equation, okay, half kx square, or you can say uh, potential energy as well, where k is a constant, okay, and the determine of the unit of k. So we have to find k unit, okay. We also know unit of w. W means work. We know the x value unit. So in question number 21, write this formula and make a subject k. So we have to find the unit of k. So work or energy, anything you say, but its unit is joule, okay. So joule here, and x square. Square means it is a distance basically. So in the SI unit we have a meter. So here square. So we do here square and substitute the value of joule here into the SI base units. So kilogram meter square upon second square to meter square, and we got the result kilogram per second square, which is a unit of K. Okay. Now this is all about question number 21. Now we move forward into the question number 22. Use base units to check whether the following equation are balanced. It is a similar kind of question in we see in question number 20. So let's see. A says power is equal to potential difference into electrical current. Now in question number 22A, this is the brightness they give us, and we take a LHS left hand side power. Power means power defined by work done per unit time. Okay. So it is a work. Work means joule. T means time. Time means second. So substitute the value of joule into the base units. So kilogram meter square per second square and second for this time. And we got the answer kilogram meter square per second cube. Okay. Now the time for RHS. RHS means potential difference. We denoted potential difference by V and electrical current by I. Okay, that I write here V and I. Now, the Ohm's formula given by V is equals to IR. So, also you can say voltage it is given by joule per coulomb means V is equals to this is also a formula for potential difference work done per unit charge. Okay, we see in electrostatics, but here they mention this potential difference. So I mentioned this equation, but the real significance and what does it mean? We see in electrostatic part. So here we only deal with its unit. Okay, so work work as a unit joule, and now Q is a charge has a unit coulomb. Okay, now put here and I means ampere. Okay, here A is in the 7 SI base unit quantity, okay, unit, but coulomb is not there in the 7 base units. So you have to convert coulomb into ampere. For that, you have to understand how to define the 1 ampere. So we define 1 ampere i- if there is a cylinder here, or you can say not a cylinder, but it is a electrical line, and there are many electrical charge here, okay, electrons. And for the current, this is the current direction. Consider this cross-sectional area A. So we defined 1 ampere current is equals to the charge 1 coulomb charge is passing through this area A per unit time, and we call as 1 ampere current. So this is all about definition. We also see in the ele electrostatics we deal with in it. So you have to just remember what is the formula here, what ampere. So you have to substitute here coulomb's value. So coulomb is equals to ampere into second. So substitute this value here, and you got the ampere into second. So you just cancel ampere and you got with joule per second, and it is a similar kind of result as we got in left hand side. So LHS is equal to RHS, and hence given equation is true or valid. Now question number 22b says electrical energy is equals to electric current resistance into time. Okay, so for B, LHS gives energy. Energy means joule. Okay, and its base unit conversion is like this. In the RHS, they mention current square resistance into time. Now we know current square means ampere. What is R? R here in the electrostatics, we will also see the what is the Ohm's law. Ohm's law is equal to like V proportional to I, and we derived formula is equal to V is equal to IR. From that, we can write like V upon I is equal to resistance. So put here the substitute the value here instead of R, write V by I. So V already we see V can be expressed by joule per coulomb. So substitute here joule per coulomb, ampere, and time. Again, coulomb is ampere into second, and we cancel it out ampere and seconds, and we left with only joule, which is same as left hand side. Hence, we can say this is the true equation. Now, this is all about 22 question, and it is very easy one. Okay, easy questions, and it is also easy question. Now, in question number 23, we show that the left hand side of the equation, pressure plus half into density into speed square is equals to constant is homogeneous. So what do you mean by homogeneous equation? Means LHS is equals to RHS. Okay, the unit is the same as in the right hand side means it is if it is a joule here, so it is joule here also. Now find the base unit of constant. So we have to find this SI base unit of constant on the right hand side. So if you want to know the SI base unit of constant and they give also a homogeneous equation, so we have to just know the SI unit of this left hand side, and if we got this answer, we can also use the same for the constant as well. So in question number 23, this formula now take a left hand side. So this is a pressure half rho into V square. For the SI base unit fine, so we do not consider 1 by 2 because it is dimensionless quantity. So pressure is the force per area plus it is the cancel it out. Rho means density kilogram per meter cube and V square V means speed or you can say velocity as well. So meter per second. Now substitute these values here and you left with kilogram per meter second square. So it is the same SI base unit of the constant as well because this formula is homogeneous. Okay. Now this is all about question number 20, 21, 22, and 23. And I think these all four questions are very easy to understand. Now we move on question number 24. In question number 24, the figure 1.11a shows the scale of the micrometer screw gauge when the two faces are moved to make contact with each other. This checks so-called uncertainty in the zero reading. In figure 11.1, 1.11b shows the scale when the gauge is tightened to an object. Okay. Here we have they shown AN micrometer screw gauge here and A what is the length of the object. Okay. In the micrometer screw gauge has least count is it about 0.01 centimeter. So, so millimeter. So you all know the least count of screw gauge is 0.1 mm. Now, before we measure any kind of object, we see here we saw this is the main scale and this is the vernier scale you can say. Okay, it contains 50 divisions or maybe 100 also. Okay, now it must be it is zero. It must be coincide with the zero. But here you see it is not zero, but it is a 12th division. It is 10th division, 11th, and 12th division. So the main scale zero reading is the coincide with 12th line of the vernier scale. So from that you can say it contains some error. Okay. So is it a positive error or negative error? Let me explain. Let's suppose that I have a micrometer screw gauge. Okay, and it is also it is zero, and the vernier scale has a zero. It means it's coincide to each other. Means it is a true or valid valid starting point. You can say after after the measurement of the object, I got the result about 12 mm. Okay, so I need not to put here 12 minus 0 means 12. So I got the answer right. But whenever you have a kind of error in the instrument, so you have to eliminate after the taking the readings. In this, after taking the reading, one got the result like here 15, 15.5 in the main scale reading plus coincide with this line with the 12th line also. So 12 into 0.01. Now we have 5 plus zero point 0.12 and we got the answer 15.62. Now I got this answer, okay, after the measure the object now. But we know this is an error, okay? So how I eliminate this error? Now you have to just identify the error, whether it is positive or negative. It means the zero, it's in a ideal situation, it should be is here is zero, but it is not zero, it is a 12th line, 12th division, you can say. So it is more than that actual value, so it must be plus. If that is a here zero, but here like the divisions on the vernier scale, but you could match with 48th or 47th division. So you have to just negative error means it is less. It should be 0 to 0, but it is lower than that. So it must be negative error. But in this case, we have a positive error because it is 12th, should be 0. So we have to minus this value to our measured value. So our measured value is 15.62. Okay, we also seen by here the main scale reading is 15.5. Okay, in the vernier scale we have a 12th division, 12 into 0.01. This is the list count of the vernier scale, and we got the result like 15.62 mm. Okay, it is a observed value, so you have to just subtract this is the error. If there is no error, so you do not need to be subtracted, but you have error in the initial. So this is the error. So the 12th division here, and its list count is scale is 0.01 mm. So we got error amount 0.12 mm. So you have to just eliminate by this amount, and we got the right result 15.5 mm. So the actual length of the object, you can say it is a 15.5 mm. Now, in B, there's a figure, consider 1.12 figure, this here, shows the scale of vernier caliper. So in the case of vernier caliper, you have a list count of zero point 0.1 mm. Okay, in the screw gauge, you have a 1 mm. Okay, try to remember it. In the vernier caliper, this is a kind of a simple rural. Okay, it has a 1 mm difference in each divisions, but in its vernier scale, this is all important here. Now, if you have to measure the, so this is a 5, this is a 5.5, okay, but in 5.5, it is more than that. So you have to just write 5.5 from the reading of the main scale. So it is the main scale and this is the vernier scale. Okay, the main scale reading is 5.5 here. You can see here into 5.6. There's no reach here, but it is in between 5.5 and 5.6. So take the lower value of it. So I will take 5.5 and you have to match these divisions with the main scale. So let's see which division is coincide with this main scale. So here you can see first is not a coincide one, second is also not, but the third one here you can see this is the first, second, and third one. Third one is actually coincide to the main scale reading. It is does not matter which scale is, but it is coincide completely. So the third one, so you have to just write the divisions of the vernier scale and into the list count means zero point 0.1. Sorry, so 1 mm. Okay, but in if you have to write in centimeter because it is in the centimeter, so 0.01 centimeter. Now here I write the zero of the vernier scale is between 5.5 and 5.6 centimeter. Here you can see the zero of the vernier scale is between 5.5 and 5.6. So you have to take lower value. It is 5.5. There is a constant between the third graduation of the vernier scale, one of the line of the fixed scale. Here I show you that the first, second, and third one is the coincide to exact coincide with the main scale reading line. Okay. Now the reading is between is 5.5 to 15.3 into mm. So one scale reading is 3 into list count in centimeters. Now it is in mm, okay, and now it is in centimeter. Now main scale reading is 5.5, you all know. So you have to just add this value. Total reading is 5.5 plus 0.03 centimeter, and this is the main value 5.53 centimeter. Now this is all about question number 24. In question number 25, they show two figures. The scale of micrometer screw, again, we deal with micrometer screw gauge. When the zero is being checked, again, when the measuring the diameter of the object, what is its diameter? Okay, we have to find the diameter of the object. Now, first, you need to see here, this is a zero, okay? So it should be 0 to 0 match, okay? But here it is not. So in this case, it is not above, this is a below of the zero, okay? This is a 49th and this is a 48th divisions. So that means coincide with the 48th division, which is below to zero. The zero here, it is matches with the 48th division. So what should you do? You have to just add because it is already a negative, already in a lower value. So you have to just add. In question number 24, we have a scenario like this. And this is the 12th division, and the zero is here. So you have to just subtract it. So you can just adjust the level here. But in this case, you have a 40th division here, zero here, zero here. You have to match this and this. So you have a negative error. Okay. So we know error is about y to 48th divisions. So it is you can count by 0 here, the 1 and 2 as well as, and 0.01 it is a list count, and you got 0.02, you take negative here, okay, because it's below the zero value. Now, once you identify the error, now go on figure B. So you got the result like here 11, 12, 12.5 here plus measure reading is 12.5, and it is exactly coincide with the 0 and 0, okay? So you have to just zeroth division and the list count is 0. So you do not do multiplication here, and you got the answer. Exact answer is 12.5 here. So it is a 12.5 millimeter. Now, the actual diameter it is? No, it is not, because it has some zero error, negative error. So you have to just subtract it 12.5 here, and the actual value is negative, okay? And you have to subtract the zero error. At the end, you have to just add this value, and you got the answer about 12.52 mm. This is your final answer. So I hope you understand the how to add, and when we use negative error and when we use positive error. Now in question number 26, the diameter of ball is measured, okay, using the meter rule. Here it is using by meter rule. A set square and illustrated in figure. They shown figure here. The readings on the ruler is 16.8 centimeter and the second one is 20.4 centimeter. Each reading has an uncertainty of 1 mm. Okay, so you have to just consider the uncertainty as well. Now, the calculate for the diameter of the ball, its actual uncertainty. Second, its percentage uncertainty. Now, they shown a figure here, and we have to measure the diameter of ball. So, the diameter of ball is about like this as well. Okay, this from this to this. This is the actual diameter. Now, they take a reading from here and from here. So, you have to just add like I mentioned here one and second reading. That's 2 minus 1, and you will get the diameter here. Very simple. Now, the solution reading 1 is they give 16.8 centimeter, which is about here, and reading 2 they give 20.4 centimeter, it is about here. And for the calculated diameter, you have to just subtract it and you will get the answer, the actual diameter. Now, but in the question, we have to calculate the actual uncertainty in a part. So A part, actual uncertainty means in the every measurement they have a 1 mm uncertainty is also here. So you have to just add for the actual uncertainty, and it will like zero point 0.2 centimeter, or you can say 2 mm. Now in part B, they ask about percentage uncertainty. We all know the percentage uncertainty means the actual uncertainty upon measured diameter into 100. Means actual uncertainty means zero point 0.2 upon the value here into 100. We all know the we do like this, okay? Um, we do like here, like this. Beta d upon d into 100. It is like this, okay? We did in our earlier questions as well. So I'm not going into deep. So this is about percentage uncertainty, and this is the actual one. And this is about 26 answer. Now, they say the suggestion alternative but more precise method by which the diameter could be measured. The meter scale, meter rule has a list count of what? 1 mm. Okay. They say, is there any possibility to measure the diameter of ball very powerful from this? This is a precision about one. So if we have a instrument, they measure list count has below the 1 mm. Yes, we have. They are vernier calipers and micrometer screw gauge. So vernier calipers has a list count about 0.1 mm, and in the meter rule we have 1 mm. So it is more precise than meter rule. But in case of micrometer screw gauge, it is the most precise value they give from the than the vernier calipers and meter rule. So if you want more precise value, then go for the micrometer screw gauge. Okay, this is the this is a suggestion to measure the more precise value of the diameter of the ball. Okay, and question number 26. This is it. Now we move forward. Question number 27. In question number 27, they give I1 and I2 are the two currents coming to junction a circuit. If there is a circuit here, and we see in the electrostatic as well, but I just illustrate here so you do not confuse. And this is a kind of junction, okay? And one current is coming from this, and second is coming from this, and they just add by I, or you can write like this I1 plus I2 because charge conservation is here. Okay, there's a no uh, there's a no wastage, or you can say there's a charge conservation. We see detail in our electrostatic. So the current I going out the junction is given by I is equal to I plus I2. So in the experiment, the values I1 and I2 determine, they also determine I1 and I2, okay, respectively. What is the value of I? So you have to just find I. It is very easy process, okay. What is the uncertainty in its value? Okay, this is the kind of, it is also very easy. So solution of 27, which is you have to just put value here. I1 is about 2 and I2 is 1.5. And if you just add, you get the answer 3.5 ampere. Now, this is the exact value of I, but there is some, uh, you can say, uncertainty in the I1 and I2. So, in I1, it is zero point 0.1, and in I2, it is a zero point 0.2 ampere. So from this uncertainty in these values, we also got the uncertainty in I also. Now, the rule for combining the uncertainty gives you have to just add whatever it is, you have to just add in the condition of uncertainty. You have to just add, and you got the answer is zero point 0.3. Now, the final answer is current is the actual one plus or minus the uncertainty of I due to I1 and I2. This is all about question number 27. Now we move forward in question number 28. It says in experiment, a liquid is heated electrically, causing the temperature to change from this value to this. Find the change of temperature. Okay, we have to find a delta T here over here with its associated uncertainty because it's shows some uncertainty here. So the initial temperature is 20 and it rise to 21.5. So you have to just do delta T. It is about 1.5 degrees Celsius, but it's the actual value. For the uncertainty, you have to just do add, and you got the zero point 0.7 degrees Celsius. The final result is 1.5 plus or minus zero point 0.7 degrees Celsius. It is a similar kind of question. 27 and 28 are similar questions. Okay. Now we go on question number 29. The question number 29, two set squares and a rule are used to measure the diameter of cylinder. Okay, you have to just measure the diameter of cylinder. Cylinder is like this is a kind of cylinder, and you have to just measure the diameter of this. Okay, simple. The cylinder is placed between the set square and the set square are aligned with the ruler. In the manner of the jaws of the calipers, the reading of the ruler is opposite ends of the diameter are these values. Reading is okay. Again, we have uncertainty. So we have to find the diameter, okay, diameter and the uncertainty. Okay. Now we also see the problem like this. So reading one, this one. So you have to just subtract it. Means this is a reading one, reading two. In between this is the diameter. Okay, two minus one. This gives diameter. For the uncertainty, you have to just add whatever uncertainty is. 0.5 y means zero point 0.1 centimeter, and the actual diameter value is 1.2 plus or minus zero point 0.1 centimeter. I hope you understand well this kind of questions, and I hope this question is very easy. Okay, now we go question number 30. Again, this is a similar kind of question. We already solved it. Okay, so it says the volume of the cylinder. Okay, determined by the measurement, measuring the diameter and length. The diameter was this value and the length has this kind of value. Both have a uncertainty, so we have to find absolute uncertainty in centimeter cube. Try to focus it not in the meter cube, okay? If you find the meter cube, the answer will be wrong. So you have to just find an answer is in a centimeter cube. So we also know the volume of the cylinder, which is a pi s square L, but they give a diameter, not a radius. So you have to just uh, substitute the value means d is equals to r and d by 2 d squared by 4l and put the values of d and l exact value which means 2.5 and 7.6 and they give answers 37.31 centimeter cube. For the absolute uncertainty in centimeter cube, the formula is like this: v is equals to pi r square l. We already saw some question like this. You have to just remove this kind of quantity, which is a dimension on this delta pi is meaningless. Okay, it has some certain value. Okay, so in delta v by v, you have a d square, so you have to multiply by 2 delta d upon d plus l has a one value, so try to multiply by 1. Okay, delta l upon l into 100, but it is a percentage. They give 9.3 percentage and you have to just multiply by it and you got 3.47 centimeter cube. It is a delta V and the final answer is 37.31 plus or minus 3.47 centimeter cube. You have to mention here, otherwise your answer will be wrong or you can get less marks. In the This is all about question number 30. Now we move forward on question number 31. The value of the acceleration of free fall was determined by the measuring the period of the oscillation t, simple pendulum length L, the relation between g, t, and L. They give a formula. Okay. In the experiment, L values this, t was measured like this, and the find the value of g, we have to find g. Okay. Okay. and the fraction and percentage uncertainty in this value. Okay, we do similar kind of question. So given L is equal to this from the question and substitute the values and you got the G value, which is 9.7 meter per second square. Now for the they ask about fractional and percentage uncertainty. Now the fractional uncertainty is we do delta G upon G is equal to delta L upon L to Y because we have T square here. So put this value here and you get the answer 0.062. Now you have to just multiply by G value, which is already we got 9.7 and you got zero point 0.6 meter per second square because it is the acceleration. So in my first video, I mentioned about do not forget the right to units. Okay, G it is actually one is 9% plus or minus 0.6 meter per second square from the fractional uncertainty. Now the percentage uncertainty it is multiplied by 100. Same kind of thing, but multiply by 100, you got 6.2 percentage. Okay, this is all about question number 31. Now we go on question number 32. Question number 32, which is similar kind of question. The value volume V cylinder determined by the measuring the radius R, length L. The relation between V, R, L, they also given. Okay. In experiment, R was measured. They give a value of L and find the value of V. Okay. From the formula, put this value here, and you got the answer like this in centimeter cube. Okay. Now they are asked about absolute uncertainty as well. So for absolute uncertainty, formula is like this. Now 2 means from this square. Okay. We do similar kind of questions many times, so I'm not getting in depth. Okay. Now we got the answer 0.046 and the final value delta V 40.02 and volume is like this. Here, one thing is here I approximate. Here it is like 870 like this centimeter cube. And here it is a 40.02, so means you can also write 40 only centimeter cube. So I just round off some figures here. So don't try to confuse yourself. Okay, you can also write like this also. But here in some question they specify about round in give answer in round of rules or they mention about round of figure or like this. That time you should or you must do uh, round off this kind of value. Otherwise, they will not mention about this. You can write like this as well. Okay. And this is all about question number 32. Now we go on question number 33. In the question number 33, the mass and the dimensions of metal rectangular block are measured. Okay. The values obtained are mass, length, breadth, and depth. Determine the density of the metal and its absolute uncertainty. Okay, again, this kind of question. Okay, so I mentioned here what is given, and we have to find the density of metal rectangular block. It is like this. Okay, so we have to know that what is the volume of it. So the volume is given by LBH, length, breadth, and height, or you can say depth also. We have a length, breadth, and depth. Put this value here. Try to put this absolute value, not just uncertainty. And if you got this value, put this here, and mass is already given. So we got the density here. It is about 8925.57 kilogram per meter cube. Now it is time to find absolute uncertainty. So formula is like this. Now formula of rho is like this. And if I substitute the value of V here, means LBH. Okay, there's no power, means multiplication by 1 with all. Okay, and you got the answer 0.06266, and you have to just add multiply by with rho this value, and you got 559.2 kilogram per meter cube. Here they didn't mention about rounding off, but here I do rounding off about uh, 8900. This very near to this. So I did, and for the 559, I write like this 600. So if you want to put this value as well as in this, it is okay because there's a no mention is rounding of value. Okay, if there is a no mention of rounding of value, you can do put this value as well. Okay, I hope you understand these questions and approach. Some questions still remain, and we will discuss those questions in my next video. Thank you for watching. Subscribe for more physics lectures.